Okay, so it's pretty simple. 0.9 times 550 is 495. So that would be your AC, right? First number in the row times the first number in the column. And then 0.2 times 450 is 90. So you're going to get 495 and 90, right? But then what are you going to do? A plus, right? So that's one step that happened. So it wasn't quite exactly right, but it's easy to fix that. So it's okay, well, is that familiar? That's what we get if we have 550, 450 for our population. That's the number sane. Okay? So this is, put the camera on yet. This is a number sane. Number sane after one transition, starting with population vector. $550, $450. And there should be no mystery to that, because everybody got the 495 and the 90. Okay? So, can you quickly write down the product you would get to get the number of demented? What numbers do you need here? One of those is right. Actually, no, you wrote 0.9.2. That's what we had for the number sane, right?
Which one's this one?
Huh?
This is for the demented.
We want to get the number of demented.
Oh, okay.
Okay, well, the first number is going to be what we multiply by 550 to get the demented, right? So what percent of our 550 sane are going to become demented? Be 20%, wouldn't it? Because this number multiplies the number sane to give us a number of demented, right? So we need a 0.2 here.
Shouldn't it be 0.1 though?
Huh?
Shouldn't it be 0.1 though? Because the remainder was 0.9.
You're right, it's 0.1. Somebody wrote down 0.2, that was stuck in my brain. Okay, 10% of the sane become demented. Okay? And then we have to multiply the number of demented by some number that contributes to the number of demented, right? So what would we multiply our 450 demented by to get our contribution to the demented people? 80% of those are going to remain demented. Okay? And straightforward what we get 55 plus 360, and that's 415. Okay? Okay, so how about this calculation? what would a reasonable result for this calculation be? Well,
Bracket with both of them.
huh?
A bracket with both of them, 585, 415.
Yeah. This is going to be 585, 415. Okay? Now, the way we look at it is when we, this is a multiplication of a matrix times a matrix, okay? This was just a row, this is just a column, but rows and columns are matrices. A matrix is just a square or rectangular array of numbers. We can be more specific about that, but it's pretty easy to understand that. So this is rectangular, it's actually square, right? Yeah. 2 rows, 2 columns, nice and simple. Okay? We multiply this row by this column, and we get 585. We multiply this row by the column, we get 415. When we multiply the first row by the column, the number goes in the first row of the resulting matrix. When we multiply the second row by a column, that number goes in the second row. Okay? This is one simple calculation. Any computer algebra system, your calculators, anything knows how to do matrix multiplication. And powers of matrices, which we're going to talk about at the end of, yeah, 17 more minutes. Should we cover the whole theory of it? Yeah. We can get all the way to Heisenberg matrices and quantum mechanics, right? Well, maybe not. Okay, I'd have to own up on that. Okay. Another thing we can do. Incidentally, notice that the columns add up to 1. And if you think about it, it's obvious that they should. But now I want to multiply this matrix by itself. Okay? Now, what do you think the scheme's going to be to multiply a matrix by itself? We know how to multiply now a matrix by a column, right? That's what we did over there, but now we have a matrix times a matrix.
Would it be go by the row, first column, you get the first point, go by the row, second column, you get the second point?
Exactly. So we multiply rows by columns. That's all we know how to do. That's all we ever do with matrices. If we multiply them. It's always rows times columns, and it's left and right. The row is on the left, the column is on the right. We never multiply a column on the left by a row on the right. Okay? So it's row times column, row times column, row times column, row times column, right? There are 2 rows, 2 columns, there are 4 multiplications. When we do this, okay, well, first row times first column, what do you get? Go ahead, I'm going to give you a minute or so and see how far you can get in multiplying this thing and where you think everything ought to go. I'm guessing that you have a good chance of guessing right, but if not, we'll correct that.